So let's start off an example here. Let's say we have a fictitious e-commerce storefront, Indies Custom Threads. And in this store, you can order customized t-shirts, kind of like my nifty API Gateway t-shirt here. So let's walk through this scenario, right? We'd have our users here, and then they would make the purchase and look at the t-shirts on the website through these different clients, right? So you'd have your web application here, which would be a standard web browser. We'd have our mobile client as well. It could be iOS, it could be Android. And then we also have a third-party API integration service, right? So this could be if you want to integrate your website with, like, say, something like Facebook, or in our case, we have a review API that's integrated through a third party. So say you see someone makes a comment about the t-shirt, and they're like, man, the t-shirt fit comfortable, but the 50% polyester really gave me a bad skin rash. That would all be possible through this third-party integrated service. So now that we established our users and our clients, now let's take a look at the actual product detail UI. So there's a lot of different functionality, a lot of different tasks that we've broken down into these microservices here. And this originally would be a monolithic application like we previously talked about, but we've broken it apart and segmented it into different services. So as you can see, the first one here is the product info service. This would be stuff like, look at the t-shirt, what kind of color is the t-shirt? Is it black, red? The size of the t-shirt, large, medium, and so on. And then we have our pricing service. We have our order service. If you want to look at, purchase history, you got the inventory service and review service and so on. And this is just a handful of different microservices here. We could have many more. So just for this presentation, we're going to keep it pretty simple. Okay. So the first architecture pattern that we could operate where we could have users communicate with these microservices would be without an API gateway. And this would be a direct client to microservice. I'm just going to put SVC for short, communication. So in this approach, in this architecture pattern, we have our clients speaking directly to our microservices, right? So say that this user here goes to the product detail UI and wants to look at the product info, right? And see what kind of shirt they have, so that it would talk directly to this service right here. And then so on, if it wants to see the pricing, right? Does another click on the UI, it would go to this microservice and so on. So this client is speaking to all these individual services right here. And this is completely fine, and this operates really well for like a small application, but as you start to grow and add more functionality and more services to your product UI page, you're going to have many more calls, right? API requests. And this is not ideal for that once you start to grow. So trying to scale something like this can be very cumbersome and be very problematic, both for the user and the development team. So let's take a look at some of those pitfalls that you may run into. The first one is too many round trips. You're probably wondering, what the hell is a round trip, right? Well, round trip in this instance is discussing going from the client all the way to the product info service, right? So again, say you don't want a black t-shirt, you want a red one, and maybe instead of large, you want to get one for your child who's a youth size, and the price goes down. So this service will need to communicate with this service, but it'll have to go all the way back, call all the way back to the client, and then go all the way back to this pricing service, and then all the way back, and so on. So as you can see, there's a lot of traffic going across the network here, and this causes a major significant latency issue. So the page load's very slow. You're going to have to wait. It's not very user-friendly. And then, again, the development experience is not great for developers because you got to maintain all this traffic, and there's just so much room for error using this model. So another issue to think about is cross-cutting, right? So by cross-cutting, this would be the issues dealing with the actual internet protocols that your clients are using. For the most part, it's most likely you'll be using like HTTPS, where the S would be a security credential that you got to get certified. But every now and then you're going to have some server-side protocols, say something like AMQP, which is an advanced messaging queuing protocol. And you're not able to do that with this model because you have to be consistent, have the same common functionality with all these services, right? So you're very limited with your resource, right? Your resource pool as far as who can operate and make a purchase on your site. Another issue is security, and this is a big one, especially nowadays as we're seeing more and more, large enterprises being hacked and so on. So in this model, all these microservices are exposed externally, right? They're all public facing, so they can operate with these clients here. So there's a lot of room getting hacked right here. So you have a larger footprint that's susceptible to getting hacked. And ideally you would have a central hub that can manage that for you. You'd have like a layer, a barrier to block you from all that. But again, this is just in this model. And the last real quick pitfall I just want to cover briefly is coupling, right? So again, as we talked about previously about the whole monolithic to microservice architecture, right? So you're taking this large application and you're segmenting it into smaller microservices, which is great, and we've done that here, but microservices over time can start to become more tightly coupled and reliant upon each other. So that's something you want to be mindful of, especially in this architecture pattern, because you have so many communication channels going back and forth. And again, like the product info service, right, was reliant upon the pricing service in certain instances. If this product info service needs to be maintained and updated, that could be contingent on this other pricing service if it's operating, and they could affect each other. So if one goes down, another one go down, it could have a cascade effect where your services aren't operational. And then, again, it's all about your user experience. It's not ideal for a user if one service goes down and they're not able to operate and another service goes down. So you really want to try to mitigate that. So coupling is another thing to be mindful of in this architecture pattern. So I hope this quick overview of direct client to microservice communication architecture has been helpful for you. Again, it's not a bad option if you're just going to have one single API that's only read-only. However, if you're going to scale out your application in the future and you're going to have much more functionality and features added, as well as having more API requests come in, then you really want to consider implementing an API gateway to help mitigate all these issues we went over in the video. So again, thank you so much for watching, and please don't forget to hit that subscribe button. As always, thank you. If you have questions, please drop us a line below. If you want to see more videos like this in the future, please like and subscribe.